In June 2026, a Chinese AI model called Kimi K2, built by a Beijing startup named Moonshot AI, scored higher than every American competitor on MLU Pro, the most comprehensive academic benchmark in existence, covering 57 subjects from medicine to law to advanced mathematics. Not by a fraction. It outperformed OpenAI's GPT-4o, Google's Gemini 1.5 Pro, and Anthropic's Claude 3.5 Sonnet across the board. The company had fewer than 400 employees at the time. The model cost a fraction of GPT-4o to run, and most people in the West had never heard of it. Here's why that should stop you cold. For the last 3 years, the United States government has operated on a single strategic assumption, that export controls on advanced semiconductors would keep China's AI development at least 2 to 3 years behind American labs. That assumption is now broken. The Commerce Department placed Nvidia's H100 and A100 chips on the restricted list in October 2023, then tightened those controls again in October 2024. The policy cost American chip companies an estimated $15 billion in lost Chinese revenue. And it did not work. Not in the way anyone predicted. The specific consequences of this moment are not abstract. They land in two very concrete places. The first is military and geopolitical. AI is now the core infrastructure of signals intelligence, autonomous weapons targeting, cyber attack generation, and satellite image analysis. A country that leads in frontier AI capability has a structural advantage in all of those domains simultaneously. The gap between American and Chinese AI systems was supposed to be the buffer. That buffer just collapsed. The second consequence is economic. American AI companies, OpenAI, Anthropic, Google DeepMind, have raised hundreds of billions of dollars on the implicit promise that they are building something no one else can replicate at the same level. If a 400-person Beijing startup can match or beat them on the world's hardest benchmark, the valuation logic for an entire sector of the American economy needs to be revisited. That is not a future problem. It is a right-now problem. To understand how we got here, you need to go back to 2017. That was the year the Chinese government published its National AI Development Plan, a document that set a single national goal: achieve global AI leadership by 2030. It was not a vague ambition. It was a funded, structured, centrally coordinated program, with explicit milestones and government procurement guarantees attached. Think of it like NASA in 1961, but for machine intelligence, and running for 13 years instead of 8. By 2022, China was producing more AI research papers than any other country. By 2023, it had more AI patent filings. What it lacked was top-tier model performance, the ability to build systems that could reason, code, and generate language at the level of GPT-4. American export controls were designed specifically to preserve that gap by starving Chinese labs of the high-end chips needed for large-scale model training. The strategy made sense on paper. The assumption was that hardware was the bottleneck. It turned out the bottleneck was somewhere else entirely. The first thing you need to understand about Kimi K2 is how it achieves its performance. It uses a mixture of experts architecture, which means it does not activate all of its parameters for every single task. The full model contains 1 trillion parameters, roughly comparable to GPT-4, but at any given moment, only about 32 billion of those parameters are actually running. The rest are dormant. This changes everything about the cost structure. A dense model, like the kind OpenAI built for GPT-4, keeps all of its computational weight active during every inference. Running it at scale is extraordinarily expensive. Kimi K2, by routing each query to only the relevant specialist cluster within the model, runs at roughly 1/6 the inference cost of comparable American systems. That is not a marginal efficiency improvement. That is a structural economic advantage. A hospital in Jakarta, a law firm in Lagos, a coding team in Sao Paulo, all of them can now access frontier AI at a price point that American models cannot match. This matters enormously for global adoption, and global adoption is what drives the feedback loop of data, revenue, and further improvement that compounds over years. The deeper revelation, the one that should genuinely reframe how you see this race, is that Moonshot AI trained Kimi K2 without access to Nvidia's restricted chips. They used a combination of Huawei's Ascend 910B processors and a domestically coordinated cluster of lower-tier GPUs, stitched together with custom interconnect software that compensated for the hardware's individual limitations. Think of it like this. American policy assumed China needed a Ferrari engine to win the race. China built a different kind of car. Huawei shipped approximately 800,000 Ascend 910B chips in 2025 alone. That number is expected to reach 1.3 million units in 2026. Each chip performs at roughly 60% of an Nvidia H100's theoretical peak, but Chinese engineers have gotten exceptionally good at closing that gap through software optimization and parallel training techniques. DeepSeek R1, the model that shocked American markets in January 2025 and briefly erased $600 billion from Nvidia's market cap in a single day, was trained for approximately $6 million. GPT, for cost an estimated $100 million. The efficiency gap is not narrowing. It is widening in China's favor. There are real problems here that deserve honest attention. The first is transparency. Neither Moonshot AI nor DeepSeek has released full technical documentation for their training processes. When Western researchers attempt to reproduce their reported results, the numbers sometimes behave differently under different evaluation conditions. Benchmarks can be gamed. Models can be fine-tuned specifically to perform well on test sets without generalizing to real-world tasks. Several researchers at MIT and Stanford have raised exactly this concern about MLU Pro scores from Chinese labs, noting that benchmark saturation is a known problem in AI evaluation. The second concern is harder to dismiss. Chinese AI models are subject to Chinese law, which requires content moderation aligned with government directives. Kimi K2 will not discuss Tiananmen Square, Taiwan's sovereignty, or Xinjiang. For many global use cases, this is not a deal-breaker. But for applications requiring unconstrained information access, journalism, academic research, legal analysis, and contested political domains, it is a fundamental limitation. The model's political filter is not a bug. It is a design requirement. That distinction matters when you are evaluating it as a global infrastructure tool. This affects you more directly than most technology stories do. If you work in software development, legal research, financial analysis, medicine, or education, the tools you use are about to become dramatically cheaper and more capable. But the question of which country's AI you are depending on is becoming a real procurement decision, not a philosophical one. By 2027, most enterprise software platforms will offer a choice of underlying AI model. The Chinese options will likely be significantly cheaper. Your company's IT department will face that trade-off with real dollar figures attached. If you are an investor or work in tech, the valuation compression risk for American AI companies is concrete and near-term. The argument that OpenAI or Anthropic commands a premium because they are irreplaceable is weakening every quarter. And if you are in policy, defense, or intelligence, the export control toolkit just lost its central assumption, and no replacement strategy has been announced. Here is the honest long view. The United States still leads in several critical areas: chip fabrication, AI safety research, and the density of top-tier talent concentrated in a small number of institutions. Those advantages are real. But the assumption that hardware control equals capability control has been definitively falsified. What comes next is a race that looks less like a sprint and more like two parallel construction projects building toward the same destination from different directions. In the next decade, the more important question will not be which country's AI scores highest on a benchmark. It will be which country's AI becomes the default infrastructure for the rest of the world, the invisible layer